So, hello, welcome to our virtual discussion. So, our discussion for today is all about mathematics in our world. So, there are three subtopics in this discussion. So, the first one is patterns and numbers in nature and the world. And second is the Fibonacci sequence. And lastly is mathematics for our world. The first one is patterns in numbers in nature and the world. So what is patterns? Patterns are regular, repeated, or recurring forms or design. So sila yung mga designs na nauulit na nakikita natin sa nature or sa ating mga kapaligiran. So, for example, is yung sa mga bahay natin ay yung floor tiles. Makikita natin na nauulit yung mga designs niya. So, I give you an example of patterns. This. So, example number 1. Ano kaya yung susunod na object or figure sa circle sa color blue circle? So, makikita natin na after the blue circle is another circle ulit, which is color red. So, therefore, yung next object is circle with color red. So, proceed tayo sa example number 2. Sa example number 2 is a set of numbers. So, there are 1, 4, 9, 16, and 25. So, we have to identify the sixth term. So, in this sample, we have to first identify the rule used in the sequence. So, the first thing we need to do is apply the subtraction. So, 4 minus 1 is 3, while 9 minus 4 is 5, and 16 minus 9 is 7, and 25 minus 16 is 9. So, anong mapapansin nyo sa mga differences nila? Tama. They are all odd number. So, the next odd number to 9 is 11. So, if we add 11 to 25, the answer would be 36. So, 36 is the sixth term. So, types of patterns is symmetry. There are other types of symmetry depending on the numbers of sides or faces that are symmetrical. Note that if you rotate the spiderwort and starfish above by several degrees, you can still achieve the same appearance as the original position. This is known as rotational symmetry. The smallest angle that a figure can be rotated while still preserving the original formation is called the angle of rotation. So, ito yung starfish and spiderwort. Makikita natin na pag ni-rotate natin siya, is symmetry pa rin. So, a more common way of describing rotational symmetry is by order of rotation. So, there is order of rotation. To compute this, we use the following formula. So, angle of rotation is equal to 360 degrees over n. So, yung n is yung fold rotational symmetry, which is kung ilang number of fold yung meron ang isang figure. For example, sa starfish, merong 5. So if we divide starfish 360 over 5, yun ang angle of rotation. So for example, yung snowflakes, The patterns of Nave's flakes is repeated 6 times, indicating that there is a six-fold symmetry. To determine the angle of rotation, we simply divide 360 degrees by 6. Bakit 6? Kasi 6-fold symmetry siya. So therefore, we get 60 degrees. So next is honeycomb. Another marvel of nature design is the structure and shape of a honeycomb. So why bees use hexagon in making honeycomb and not any other polygons? So we will find out later. So packing problems involve finding the optimum method of filling up a given space such as a cubic or spherical container. Let us illustrate this mathematically. Suppose you have circles of radius 1 cm, each of which will then have an area of 5 cm squared. We are then going to fill a plane with these circles using square packing and hexagonal packing. So sa square packing, each square will have an area of 4 centimeters squared. Note from the figure that for each square, it can fit only one circle, which is 4 quarters. The percentage of the square is area covered by circle will be, so there is a formula. Area of the square circles rather over area of the square times 100%. So is equal to, given na yung pi centimeter squared. Pi centimeter squared over 4 centimeter squared times 100% is equal to, or approximately to, with a approximate value 78.54%. So for hexagonal packing naman, we can think of each hexagon as composed of 6 equilateral triangles with side equal to 2 centimeters. The area of each triangle is given by area is equal to side squared times square root of 3 over 4 is equal to, so we substitute the given sa formula. So 2 centimeters squared, yung side is 2 centimeter. So we will have to raise it to 2 times square root of 3 over 4 is equal to 4 centimeters squared times the square root of 3 over 4 is equal to square root of 3 centimeters squared. So yun ang area ng triangle. So if we have to answer the question previously, which is why bees use hexagon in making honeycomb and not any other polygons. So we have to hindi naman natin mako-compare yung square packing sa hexagon kung yung hexagon packing is nakuha natin is hindi percentage. So if gagawin natin percentage yung sa hexagonal packing, this will be the result. So area of circles over area of the square times 100% is equal to 3 pi centimeters squared over 6 the square root of 3 centimeters squared times 100% is approximately equal to 90.69%. So comparing the two percentage, we can clearly see that using hexagon will cover a larger area than using squares. So ito yung sagot natin sa question previously. Mas malaki yung mako-cover ng hexagon kasi sa square. Patterns are also exhibited in the external appearances of animals. We are familiar with how a tiger looks distinctive, reddish-orange fur and dark stripes. It can also be found in hyenas, another predator from Africa, are also covered in pattern spots. Next is the sunflower. Looking at the sunflower up close, you will notice that there is a definite pattern of clockwise and counterclockwise arcs or spirals extending outward from the center of the flower. This is another demonstration of how nature works to optimize the available space. This arrangement allows the sunflower seeds to occupy the flower head in a way that maximizes their access to light and necessary nutrients. We are also very familiar with spiral patterns. The most common spiral patterns can be seen in the werewolves and in the shells and other similar mollusks. Snails are born with their shells called protoconch, which start out as fragile and colorless. Next are flower petals. Flowers are easily considered as things of beauty. If you look more closely, you will notice that different flowers have different numbers of petals. Some of them have 3 petals. For example, are iris and trillium, while others have 5. For example, are buttercup, columbine, and hibiscus, and others have 8. For example, are clematis and delphinium, while ragwort and marigold have 13. These numbers are all Fibonacci numbers that we will discuss later on. Next is the world population. Mathematics can be used to model population growth with a formula A is equal to PE raised to R and T, where A is the size of the population after it grows, and P is the initial number of people. R is the rate of growth, and T is time, and E is the Euler's constant with an approximate value of 2.718. So example of population growth, the exponential growth model A is equal to 30e raised to 0.02 t describes the population of a city in the Philippines in thousands years after 1995. So what was the population of the city in 1995? Solution. Since our exponential growth model describes the population years after 1995, we consider 1995 as t is equal to 0 and then solve for a, which is our population size. So, here is our computation. A is equal to 30e raised to 0.02t. A is equal to 30e raised to 0.02 times 0. A is equal to 30e raised to 0, which is kapag tinimes mo yung 0.02 to 0 is equal to 0 pa din. So, next, A is equal to 30e times 1 kasi e raised to 0 is equal to 1. So A is equal to 30. Therefore, the city population in 1995 was 30,000. Next, the number 2 problem, what will be the population in 2017? So we need to find A for the year 2017. To find T, we subtract 2017 and 1995 to get t is equal to 22, which we then plug it into our exponential growth model. So here's our computation. A is equal to 30e raised to 0.02t. A is equal to 30e raised to 0.02 times 22. 30e is 30e raised to 0.44 kasi 0.02 times 22 is equal to 0.44. A is equal to 30 times 1.55271 is equal to A is equal to 46.5813. Therefore, the city population will be about 46,581 in 2017. So the next topic is the Fibonacci sequence. What is sequence? It is an ordered list of numbers called terms that may have repeated values. The arrangement of these terms is set by a definite rule. So for example, 1, 1, 2, 3, 5, and 8. Looking at the set of numbers, the succeeding terms in the sequence can be generated by adding the two numbers that came before the terms. So ganito yun. 1 plus 1 is equal to 2, 2 plus 3 is equal to 5, 5 plus 3 is equal to 8. So, hence, by applying the rule, the next three terms are 13, 21, and 34 because 8 plus 5 is equal to 13 and 8 plus 13 is equal to 21 and 21 plus 13 is equal to 34. So this sequence is a special sequence called Fibonacci sequence. So what is Fibonacci sequence? It is named after the Italian mathematician Leonardo of Pisa, who was better known by his nickname Fibonacci. He is said to have discovered this sequence as he looked at how a hypothesized group of rabbits bred and reproduced. He noted that the set of numbers generated from this problem could be extended by getting the sum of the two previous terms. Fibonacci sequence has many interesting properties. It is also interesting to note that the ratios of successive Fibonacci numbers approach the number p, also known as the golden ratio. This is approximately equal to 1 and 6/1800. So sa right side makikita natin yung value ng golden ratio, which is yung 1.6/1800. So the golden ratio. The golden ratio can also be expressed as the ratio between two numbers. If the latter is also the ratio between the sum and the larger of the two numbers, geometrically it can also be visualized as a rectangle perfectly formed by a square and another rectangle which can be repeated infinitely inside each section. So yung nasa right side na picture is the golden rectangle with the golden spiral. So shapes and figures that bear this proportion are generally considered to be aesthetically pleasing. As such, this ratio is visible in many works of art and architecture such as in the Mona Lisa, the Notre Dame Cathedral, and the Pantheon. In fact, the human DNA molecule also contains Fibonacci numbers, being 34 angstroms long by 21 angstroms wide for each full cycle of the double helix spiral. So, as shown in the picture, so this in the right side, this approximates the golden ratio at a value of about 1.6/1900. So, yung nasa 34/21, which is 1 angstrom is equal to 10 raised to negative 10 meter or 0.1 nanometer. So, there are 4 applications of mathematics. So the first application is mathematics for organization. A lot of events happens around us. In the blink of an eye, several children have already been born, liters of water have been consumed, or thousands of tweets have been posted. For us to make sense of all available information, we need mathematical tools to help us make sound analysis and better decisions. For instance, a particular store can gather data on the shopping habits for its customers and make necessary adjustments to help drive sales. Next is scientists can plot bird migration routes to help conserve endangered animals populations. Next is social media analysts can crunch all online postings using software to gauge the netizens' sentiments on particular issues or personalities. So, in conclusion, mathematics helps organize patterns and regularities in the world. So, the next application is mathematics for prediction. It is sometimes said that history repeats itself. As much as we can use mathematical models using existing data to generate analysis and interpretations, we can also use them to make predictions. Applying the concept of probability, experts can calculate the chance of an event occurring. The weather is a prime example. Based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us of weather disturbances that can affect our activities for weeks or months. Astronomers also use patterns to predict the occurrence of meteor showers or eclipses. In 2017, announcements were made about heavenly phenomena such as the Draconid meteor shower and the Great American Eclipse. They were able to tell when these phenomena would occur and where would be the best places to view them. So in conclusion, mathematics for prediction, the mathematics help predict the behavior of nature and phenomena in the world. So in summary, mathematics help predict the behavior of nature and phenomena in the world. So the third application is mathematics for control. We have demonstrated by means of examples around us that patterns are definitely present in the universe. There seems to be an underlying mathematical structure in the way that natural objects and phenomena behave. While photographers could capture a single moment through a snapshot, videographers could record events as they unfold. Painters and sculptors could create masterpieces in interpreting their surroundings. Poets could use beautiful words to describe an object, and musicians could capture and reproduce sounds that they hear. These observations of nature, as well as their interactions and relationships, could be more elegantly described by means of mathematical equations. As stated by astrophysicist Brian Greene, with a few symbols on a page, you can describe a wealth of physical phenomena. It is interesting then to ponder on how mathematics, an invention of the human mind, seems to permeate the natural laws that hold the universe together. There have been instances when a natural phenomena has been speculated to exist because mathematics says so, but no hard evidence have been found to support its existence. Such phenomena were proven to exist only when advancements in technology have allowed us to expand our horizons. For example, in 1916, Albert Einstein hypothesized the existence of gravitational waves based on his theory of general relativity. This is when ripples are formed in the fabric of space-time due to large and violent cosmic events, very much like when a pebble is thrown in a stagnant pond. About 100 years later, the Laser Interferometer Gravitational Wave Observatory, or LIGO, announced that it found evidence of this phenomena. Though the use of mathematics, man is also be able to exert control over himself and the effects of nature. The threat of climate change and global warming has been the subject of much debate over the years. It is believed that unless man changes his behavior, patterns are said to indicate that sea levels could rise to catastrophic levels as the polar caps melt due to the increase in global temperatures. To ensure that greenhouse gas concentrations in the atmosphere are kept at levels that will not interfere with the climate system, the United Nations Framework Convention on Climate Change was signed in 1992 and has 197 parties as of December 2015. So in summary, mathematics for control, hel- it's that mathematics helps human exert control over occurrences in the world for the advancement of our civilization. So the last thing is mathematics is indispensable. So what is the meaning of indispensable? It means that it is necessary. In this chapter, It was highlighted how mathematics plays a huge role in the underpinnings of our world. We have seen it in living creatures and natural phenomena. We have also looked at examples of how mathematical concepts could be applied, whether you are on your way to becoming a doctor, an engineer, an entrepreneur, or a chef. A knowledge of mathematics will be helpful. At the most basic level, logical reasonings and critical thinking are crucial skills that are needed in any endeavor. As such, the study of mathematics should be embraced as it paves the way for more educated decisions and in a way bring us closer to understanding the natural world. So, in conclusion, mathematics has numerous applications in the world, making it indispensable. And that's all for today. Thank you.
So first, what is problem? It is a statement requiring a solution, usually by means of mathematical operation or geometric construction. Next is problem solving. Problem solving is a process of an ongoing activity in which we take what we know to discover what we know. The third one is mathematical reasoning. It refers to the ability of a person to analyze problem or situation and construct logical arguments to justify the process or hypothesis. To create both conceptual foundation and connection in order for us to be able to process the information. So, what is inductive reasoning? It is the process of reaching a general conclusion by examining a specific example. The inductive reasoning is used to predict number. Example, 3, 6, 9, 12, 15. So, what is the next number? Each successive number is 3 larger than the preceding number. Thus, we predict that the next number in the list is 3 larger than 15, which is 18. So, nalaman natin kung anong susunod na number sa pamamagitan ng addition, which is 15 plus 3 is equals to 18. The next one is deductive reasoning. It is the process of reaching a conclusion by applying general assumption, procedures, and principles. So here is the example of deductive reasoning. If a number is divisible by 2, then it must be even. 12 is divisible by 2, therefore 12 is an even number. The deductive reasoning is commonly used in geometry. This is an example of geometric equation. Solve for x in the equation 3 times x plus 4 minus 2x equals 20. Justify your answer. So, the statement and reason are given. 3x plus 4 minus 2x equals 20 is the given. 3x plus 2 minus 2x equals 20. Reason, it is the distributive property. 3x plus 12 minus 2x equals 20 is a communicative property. X plus 12 equals 20 is a closure property. X equals 20 minus 12 is transposition. So, the answer is x equals 8 is the final property or the closure property. Intuition and proof. Intuition is used by modern mathematicians, means an accumulation of attitude, including beliefs and opinions, derived from experience both individual and cultural. It is closely associated with mathematical knowledge, which form the basis of intuition. Proof. A mathematical proof is an inferential argument for a mathematical statement showing that the stated assumption logically guarantee the conclusion. Types of proof: direct proof, proof by contradiction, proof by induction. Direct proof. A direct proof is showing the truth or falsehood. of a given statement by the straightforward combination of established facts, usually axioms, existing lemmas, and theorems without making any further assumptions. Proof of contradiction. In logic and mathematics, proof by contradiction is a form of proof that establishes the truth or the validity of a proposition by showing that assuming the proposition to be false leads to be contradiction. Proof by induction. A proof by induction consists of two cases. The first is the base or basis proves the statement for n equals 0 without assuming any knowledge of other cases. The second case, the induction step, proves that if the statement holds for any given case, n equals k, then it must also hold for the next case in n equals k plus 1. So, here is the next topic, Polya's problem solving strategies. Here is the Polya's 4-step problem solving strategies. Understand the problem, devise the plan, carry out the plan, review the solution. So in understanding the problem, can you restate the problem in your own words? Can you determine what is known about this type of problems? Is there missing information that, if known, would allow you to solve the problem? Is there extraneous information that is needed to solve the problem? What is the goal? So, ito yung mga kailangan para malaman mo at maintindihan yung problem ng isang equation. The second one is devise a plan. So, in devising a plan, there are many processes. The first process is make a list of the known information, make a list of information that is needed, draw a diagram, make an organized list that shows all the possibilities, make a table or chart, work backwards, try to solve a similar but simpler problem, look for a pattern, write an equation if necessary, define what each variable represents, perform an experiment, guess at a solution, and then check your result. The third one is carry out the plan. In carrying out the plan, you need to work carefully, keep an accurate and neat record of all your attempts, realize that some of your initial plans will not work and that you may have to devise another plan or modify your existing plan. So, when you are carrying out the plan, di ka makakasigurado kung tama na ba yung nagawa mo. Kailangan mo pang ulitin o kaya baguhin yung plan na ginawa mo. So, the last one is review the solution. Ensure that the solution is consistent with the facts of the problem. Interpret the solution in the context of the problem. Ask yourself whether there are generalization of the solution that could apply to other problems. This is an example of Polya's problem solving strategies. A baseball team won 2 of their last 4 games. In how many different order could they have 2 wins and 2 losses in 4 games? Understand the problem. There are many different orders. The team may have won 2 straight games and lose the 2. Or maybe they lost the first 2 games and won the last 2. Of course, there are other possibilities such as win-loss, win-loss. The device plan of this example is make an organized list of all possible orders. So when carrying out the plan, you should know the patterns, which is win-win, loss-loss, win-loss, win-loss, win-loss-loss, win, lost-win, win-loss, lost-win, lost-win, lost-lost, win-win. So in reviewing the solution, the list has no duplicate and the list considers all possible. There are 6 orders in which baseball team can exactly won 2 of the last games. So the third topic is problem solving strategies. The first problem solving strategies is guess and check. When you are not sure how to start, guess an answer and then check it. In the process of checking a guess, you may see a way of revising your guess to get to, to get closer to the answer or to get the exact answer. The second strategy is to make a table and look for a pattern. Some problems describe relationships that involve regular sequence of number or other things. To solve the problem, you need to be able to recognize and describe the pattern that gives the relationship for the numbers or thing. One way to recognize the information given is make a table. The next one is make an organized list. Making an organized list will lead you to work logically and systematically. The following strategies is work backwards. To solve the problem, you need to start from the end result and work backward to the beginning. The last one is write and solve equation. Algebraic expressions are used to represent information and solve problems. We use a variable for the unknown quantity and express the given information in an equation. Problem solving with pattern. Terms of a sequence, an ordered list of numbers such as 5, 14, 27, 44, and 65. So what is the next term? Before that, we just need to determine what is sequence. A sequence is a function whose domain is a set of positive integers. It also means an ordered list of numbers. Each number in a sequence is called a term. So the problem is 5, 14, 27, 44, and 65. What is the next term? As follows. A sub 1 equals 5, and a sub 2 equals 14, a sub 3 is equals to 27, a sub 4 is equals to 44, and a sub 5 is equal to 65. A sub n is equal to the ninth term of the sequence. So here we go. We just find the answer in this slide. Sequence 5, 14, 27, 44, 65, 90, 65. So the first differences is 9, 13, 17, 21, and 25. The second differences are 4, 4, 4. So when we add 65 plus 25, it equals to 90. So the next following term is 90. The next is the Fibonacci sequence. The Fibonacci sequence is a series of numbers such that the next number is found by adding up the two numbers before it. So f of n equals f times f of n minus 1 plus f times n minus 2, where f of n is the term number n and f times n minus 1 is the previous term n minus 1. F of n minus times n minus 2 is the term before, that is n minus 2. Recreational problem using mathematics. What is recreational mathematics? Recreational mathematics is the mathematics done recreation or as hobby and intended to be fun. Typically, it involves game or puzzles that relate to mathematics, although the term can cover other material. Example of recreational problem using mathematics. Number 1 is Tower of Hanoi. Number 2, Sudoku. Number 3 is Stick Puzzle. Tower of Hanoi is a logical puzzle frequently studied in cognitive psychology and used as a test of problem-solving ability consisting of 3 pegs, on one of which are placed a number of discs of varying diameter, the largest at the bottom. Sudoku, the popular Japanese game puzzle, Sudoku is based on the logical placement of numbers A game of logic, Sudoku doesn't require any calculation nor special math skills. All that is needed are brain and concentration. Stick puzzle. The stick puzzle is a logic mathematics problem. It can be solved by process. The stick is the main variable in this recreational solving.
Good day, everyone. I am Jerick Espenilla, BET Architectural Drafting 1A student. So today allowed me to discuss about data management. So what is data management? Data management is a process by which information is acquired and processed to ensure the accessibility and reliability of data for its user. The data gathered can be properly statistic. It is a science of which deals with the collection, organization, presentation, analysis, and interpretation of data so as to give a more meaningful information. Number two is descriptive statistic. Refers to the collection, organization, and presentation of data, while inferential statistic deals with the interpretation and analysis of data where a statistic is drawn based from the subset of the population. So, okay, number one, content of data management is measures of central tendency. So, measures of central tendency is a single value that is used to identify the center of the data set or set of observation. So, three common use measure of central tendency is the mean, median, and the mode. So, let's find out what is mean, median, and mode. So, okay. Mean, also known as the arithmetic average, is the sum of all the observed values divided by the numbers of observation in the dataset. It is the most commonly used measure of central tendency. When we speak of average, we always refer to the mean. How to get the value of mean? So here is the formula for mean. So now let's focus with the example. 6 students in B search of 20 students receives test grade of 90, 82, 88, 85, 92, and 87. So find the mean of this test score. So now we're going to add the observation list. 90 plus 82 plus 88 plus 85 plus 92 plus 87 is equal to 526 divided by 6. So we're going to divide 526 by 6. So 526 divided by 6 is equal to 87.33. Therefore, the mean is 87.33. Okay, 87.33. So, wait lang. Clarification, kung tinghali ang 6, ang 6 tabi is a total number of observations. So, okay po? Okay, median, it is the midpoint of the data Ri. Before finding this value, the data must be arranged in order from less to greatest and vice versa. The median will either be a specific value or fall between two values. Take note that if the given observation is an odd number, therefore, there is only one median or the middlemost value of the observation. And if the given observation naman is an even number or contains of a total less number, therefore there are two middlemost values. So, if n or the data is an even, the median is the average of two middlemost values. It can be computed as median x sub of 1 plus x sub of 2 over 2, where x sub of 1 and x sub of 2 are the two middlemost values. Take notes that the observations are first arranged in an array form from less to greatest. So, okay. Median, example niya is ito. Find the median of the following 9, 22, 16, 31, 8, 27, and 30. So first to do, arrange them in ascending order from less to greatest. 8, 9, 16, 22, 27, 30, and 31. So, since the given observation is an odd number, which it contains of 7 numbers, therefore the middlemost value of the observation is 22. Okay, 22. Since saro lang man siya. Okay? Or, yun nga, odd number ang observation. Okay, another example is ito. Find the median of the following. 28, 16, 30, 10, 21, 19, 7, 26, 37, 45, and 11. So, first, arrange them ascending order. 5, 7, 10, 11, 16, 19, 21, 26, 28, 30, 32, and 40. So, ito po yung formula to get the median kapag even number ang observation. So, x sub of 6 plus x sub of 7 over 2. X sub of 6 and x sub of 7 dahil sa observation less, ang middlemost value is ang pang-anom at ang pang-pito, which is this 19 and 21. So, therefore, 19 plus 21 equals 40 divided by 2 equal 20. So, ang median niya is 20. Okay po? So, next, mode naman tayo. Ang mode, it is the value that occurs most often in the dataset. The numbers, values, observation, and dataset which appears the most number of times. Okay? Example number 1. Find the mode of the given data. 8, 20, 31, 36, 24, 9, 12, 36, 37, 11, 36, 26, 29, 20, 6, 40, and 44. So, yun nga, arrange them in the data in the ascending order. 8, 6, 8, 9, 11, 12, 20, 20, 24, 26, 29, 31, 36, 36, 36, 37, 40, and 44. So, in the given data, the number appeared the most number of times is 36. The dataset is said to be unimodal. So, 36 yung naulit ng maraming beses. Naka siya unimodal dahil sarang number lang nga ang naulit ng marami. So, okay, next example. Example number 2. Okay, find the following mode. 10, 21, 24, 16, 10, 8, 31, 19, 24, and 36. Okay, again, arrange them in an array form from less to greatest. 8, 10, 10, 16, 19, 21, 24, 24, 31, and 36. Okay, thus the dataset has the two modes, 10 and 24. The dataset is said to be bimodal. So, naging bimodal dahil sa observation less, duwang number ang naulit pareho. So, ito na nga ang 10 and 24. Okay, next. Example number 3. Okay, find the mode of the given data 5, 8, 9, 10, 20, and 24. So, as we observe that wala po siyang repetition of number, therefore, there is no mode. Okay po, and that's for today. Thank you for watching and for listening. Okay, again, I am Jerick Espenilla from BET Architectural Drafting 1A. So, I hope that this video will be helpful to you. And, yun lamang po. And thank you. Thank you for watching. Good day everyone. Again, I am Jerick G. Espenilla BET Architectural Drafting 1A. So, today's lesson is the continuation about data management. Lastly, we discuss about measure of central tendency. So, for today, we're going to discuss about measures of dispersion. So, what is measure of dispersion? Measure of dispersion, it is a quantity that measures the spread of variability of the values in a given set of data. The three most common use of measure of dispersion are the range, variance, and standard deviation. So, range, it is the difference between greatest and smallest value. It's the statistical measure of dispersion highlighting how different the numbers are. Example, compare Anna and Elsa's performance in school based on their rating in 5 long quizzes. Anna got Anna got 80, 91, 88, 86, and 85, while Elsa got 88, 80, 87, 92, and 83. So, si Anna nakakuha ng highest score na 91 and the lowest score of 80. So, to get the range, we're going to subtract the highest score and lowest score of Anna. So, 91 minus 80 is equal to 11. So, Elsa naman ay nakakuha ng highest score na 892 and the lowest score of 80. Range 92 minus 80 is equal to 12. Thus, Elsa has the highest range of 12. So, yan po ang pagkuha ng range in minus ang highest and lowest score para makuha ang range. So, next, standard deviation and variance is the positive. Standard deviation is the positive square roots of the variance. Ang variance naman is the average of square deviation of every observation from the mean. Sample variance, so ito yung sample variance. So the population of variance is ito po yung magiging formula ng variance. Tapos ang standard deviation naman of the sample is ito po. So, okay, let's go with the example. So, example, the following are the score of 5 students in all of their exam and biology: 81, 86, 88, 90, and 85. Let's compute the standard deviation. So, to compute the standard deviation, we're going to make a table like this. So, 81, 86, 88, 90, and 85 with a total of 430. So n equals 5. So we're going to divide 430 to n to get the mean. 430 divided by 5 is equal to 86. So, para naman makuha na x sub of 1 minus mean is we're going to subtract. Okay po. 81 minus 86 is equal to negative 5 and 86 minus 0 is equal to 86 minus 86 is equal to 0. 88 minus 86 is equal to 2. And 90 minus 86 is equal to 4. And 85 minus 86 is equal to negative 1. Okay, to get this about this ano naman is we're going to get the squared of this. Okay po. So negative 5 squared is 25. 0 squared is 0. 2 squared is 4. 4 squared is 16, negative 1 squared is 1. So therefore, the value is ito po. So, ito po ang value, 46. So, to get the variance, we're going to use this. Okay. So, since we already get the value of this, which is 46, so n minus 1, so we're going to 5 minus 1 is equal to 4. So we're going to divide 46 divided by 4 is equal to 11.5. And okay, sa paggawa naman ng standard deviation, we're going to use again the value of this. Okay, so s squared equals s squared radical something. So 46 over 4 is equal to 33.4. So, yun po. So, the variance is 11.5 while the standard deviation is approximately 3.4. Okay po. So, thank you for watching and for listening, and hope this video is useful and helpful para sa inyo. So, okay. Okay, thank you and good day everyone.